We have this formula that gives Coulomb's force. So this formula is the constant, this constant here, which is Coulomb's constant, times the product of the two electric charges divided by r squared, which is the distance. R is the distance between the two charges, Q1 and Q2. This is Coulomb's constant. And the measurement here is Newton times square meter divided by Coulomb squared. Q1, Q2 are the two electric charges in Coulomb, and R is the distance between the charges. Let's see the impact that the distance has to the force imposed between the two charges Q1 and Q2. So mathematically, we have F1 equals the first Coulomb force equals to this formula. And I assume that Q1 and Q2 have the same sign. Let's assume that they are electrons. This is the distance between the two charges, R1. Now let's take F2, where the distance is R2 and it's twice the distance of R1. This is R2 to R1. Now let's take the ratio of the two forces. From here I can simplify this fraction and I have R2 divided by R1 squared. R2 is twice the distance R1 divided by R1 squared. So this is 4. The force F2 equals a quarter of a force F1. So from here F2 is less than F1. What happens is that when I increase the distance between the two charges, if I double the distance, then it means that the F2 attenuates. So the force imposed between the two charges decreases as I increase the distance. Now let's take another scenario. I rewrite the formulas for the two forces. And now this is initially the distance between the two charges. Now R2 equals R1 divided by 2. I decrease the distance between the two charges. The ratio of the two forces is the following. R2 is R1 divided by 2 times 1 divided by R1 squared. So it's 1 over 4. F2 equals 4 F1. Which means that F2 is greater than F1. As I decrease the distance between the two charges, the repulsive power, the repulsive force between the two charges becomes bigger. So I bring these two charges closer, Coulomb force becomes bigger and bigger. In the previous case, I double the distance and the force attenuates, becomes smaller and smaller as I increase the distance. Coulomb's force is a very important phenomenon in electrostatics, and I suggest that you have a look at the sources available on the net, because you can find many interesting things there.